So for number one, you're asked to find the midpoint of those segments. So probably the best thing is to plot those points, right? So if I have AB, yeah, AB is obviously at -2.5, B is at -1, C is at -4, -1. And remember we talked about the midpoint's the average of the XY coordinates. Or you could just look at the graph itself, right? See, here's A, here's B. And what's halfway between for X? Clearly -1.5, -3/2. What's halfway between for Y? Which would be 3/2 or 1.5, right? Because you're at -5 to 7. Half of 7 is 3.5. So if you have 3.5, you're right there. So if I draw it on the screen here, it should be, yeah, like somewhere over here roughly. Like, yeah, go ahead, Bell. Yeah. I could be wrong. Let's see. For BC, see, for BC, should be negative. No, I think I got it. It should be -2.5 and -1.5.
Yeah.
Yeah, it should be like right here. Yeah. Yeah, because what you're doing is you're averaging -2 and -1, which adds up to -3, and gotta divide by 2. Yeah. Yeah, I think okay. That's up to you. Doesn't matter. Doesn't matter. And AC should be -3, 2. Yeah, that's like right smack in the middle there. So if I were to actually draw these segments, yeah, and then you would have clearly these midpoints, kind of like this here. So that's kind of what's happening. Okay. So hopefully we got some corrections there. We're okay. All right, good. Okay, moving right along. Number two, if you find the distance, actually, I was kind of dumb. I should just left. Okay, I'll just keep what I have up here. So, all right. So if I want to find a distance, right? We talked about Pythagorean theorem. Like, so this, let's label this. That's A, B, and C. So if I label it, if I draw it, it's not quite accurate. Clearly, I want one right, not two right, so that's a little off. I want one right and 7 down. So if you do Pythagorean theorem, you got to do 1 squared plus 7 squared. What's 1 squared plus 7 squared? Right, so you make it root 50. Then for BC, I'm going this way. Okay, I need steady hands and I need a stylus. Whatever. Okay, you're going 3, 3 right, or sorry, 3 left and 1 up. So you go 3 this way and 1 up. That's 1 squared plus 3 squared, should be root 10. And for the last one, looks like you're going 6 up and 2 right. 6 up, 2 right. So what's 6 squared plus 2 squared? 40. 40. So you're gonna have root 50, root 10, and root 40 for those segments. And root 50, by the way, could be simplified as 5 root 2, because 25 is a factor of 50. That's a perfect square. And root 25 is 5. So it is encouraged that you should pull stuff out. You can. But the factor of this has to be a perfect square. And likewise, root 40. There's a 4 as a factor of 40. Pull it out. And then actually, it's kind of better if you don't simplify it, to be honest with you. Because if you think about it, what happens if you square this and square this? That's 10 plus 40. What happens if you square this? That's 50. So without realizing it, this is actually a right triangle. The way it was drawn, because the way it's oriented, is kind of funny. But if you kind of like tilt your head a little to the right, you guys kind of see how that could be a right angle here? Okay. For those who actually, and I'm sure you guys did this in Algebra 1. Did you guys learn about when lines are perpendicular, how their slopes are related? Do you guys like when two lines are parallel, they have the same slope? When two lines are perpendicular, do you know what kind of slopes they have? Remember what we call it? Negative, reciprocal? Okay, good. Okay, good. You do remember. Yeah, if I were to find the slopes of these, it's kind of just a good quick discussion because we should have this discussion because I think we're gonna have it tomorrow. Um, if you look at AC, the slope of AC, that should be up 6, right 2, so it should be a slope of 3. That's slope of -1/3. So that's also more evidence that this would be a right angle because the slopes are negative reciprocals. Because what's the reciprocal of 3? If you flip 3, 3 is 3/1. If you flip it, it becomes 1/3, and change the sign of it, it becomes -1/3. Whenever that happens, or the product of the slopes is -1, the lines are perpendicular. That'll always be true. So that's even more evidence it's a right triangle. And scaling because all sides are different. So there's a definitely right angle, and also it's scaling. And that's with using Pythagorean theorem. Okay, for 4. Again, I did this like about 25, 30 minutes ago. So if I made a mistake, please let me know. My handwriting sucks, so I apologize. Did not do very well handwriting when I was a little kid. So for number 4, move the 8 over and just factor. That's pretty easy, x plus 4, x plus 2. But solving, so you got to go a step further and tell me what x equals. The one thing on that pretest we had a couple days ago, some of you guys were factoring correctly and then stopping and not solving. If you're asked to solve, you got to go a step further, right? And say, hey, great, it's factored, but now let's tell me what x equals, -4 and -2. And then for next one, p squared equals 4, so p equals plus or minus 2. What I decided to do is that, actually, I should have factored. That was kind of dumb because I didn't pay attention to directions. If you factor it, it's actually going to be p minus 2 and p plus 4. Yeah, sorry about that. But still, you get 2 and -2. For 5, best thing to do here is to move the 7 over. Sorry, 6. Move the 7 over, you get -18. And multiply AC, that's -90, -27 down below. What two numbers multiply -90 add to -27? 3 and -30, of course, right? 3 and -30. So yeah, so you get -27. I'm sorry, say again. Oh, -5/3 and 6. Um, no, it's not -5/3. I made a mistake. I told you I knew it was gonna be a mistake. It's -3/5. My apologies. So I'm gonna do this fast. -3/5 and 6. My apologies. But yeah, if you factor it, do the diamond. I strongly recommend that because it's kind of a crazy factoring problem. AC is -90, B is -27. Two numbers that multiply -90 add to -27 are 3 and -30. You have 5x squared -18, you got 3x -30x, factor things out, work it out, you should get that. -3/5 and 6. Okay, for 9, when you do quad form, move everything to one side. So you get 5x squared minus 7x plus 2 equals 0. Negative b plus or minus the square root of b squared minus 4ac over 2a. So you have 7 plus or minus root 49 minus 40. Is that right? Yeah. Yep. So this becomes 9 underneath the radical. So 7 plus 3 over 10 or 7 minus 3 over 10. So you should get 1 or 2/5. The problem with 10 is that this won't be real. If you do quad form, you'll have a negative underneath the radical. And you guys haven't learned about complex numbers yet. You will in Algebra 2 about a year and a half from now. But there's no real solution for that one. So, and I think the same is true for 11. For 11, if you move everything to one side and do the quad form, again, you get the same scenario. You have a negative underneath the radical. Can't do anything about it. It's not real. You get no real solution also. Do you guys agree with 9, 10, 11? Okay. In 9, again, that was pretty straightforward. Just you get two numbers there. Sometimes you do get a situation with quad form where the number underneath the radical is positive, but not a perfect square. So you leave it alone, like we had on the board. Or it might have a factor as a perfect square, you pull it out. Actually, we have something like that on the pretest. We'll look at that in a moment. For simplify, 10 root 2, 7 root 3, 8 root 5. I'm pretty sure these are correct, and 2 root 2. Okay, so we will have another homework quiz today. I haven't graded the homework quiz from yesterday. I'll do that during the break or while you guys are doing some work. The homework quiz says we have factoring. a second condition postulate question with factoring, and some simplifying radical. So it's going to be um, not quite. This is some review of old stuff, but it definitely be more like day 2 homework. So um, that's day 3 homework. So we're good. And I still got to update Schoology. I'll hopefully get to that this afternoon. Okay, we're cool. Good. All right. Let's talk about the pretest. So you guys should have it. I gave back the pretest yesterday, and I think it's in my folder here. Nope, that's your responses. Here we go. Nope, hold on. I know I scanned it. Maybe I did not. Nope, sorry. Okay, well, let me take a quick picture with my. That's weird. Okay, let me take a picture with my phone. Let's see, the answers are right. Okay, do you want you making corrections on the? So get your pretest out and let's go through it. Email back here. Okay, here we go. So for number 1, um, make a correction. I think most of you guys got this one factored correctly. Just find two numbers that multiply -48 and add it to -13, so -16 and 3. So that should be fine. Um, any questions there? No. Okay, for 2, notice there's a common factor. What's a common factor here? 2x, right? So you pull it out, you get x squared minus 49. Okay. And then x squared minus 49 is not fully factored yet. X minus 7, x plus 7. Actually, I just thought of this. This is a really good thing that I think will help you guys. Just popped in my head. I think I'll print this for you guys too. Yeah, here we go. Factor and flowchart. If you guys think this could help, I totally will print this for you guys. So usually when you see like let's say you have two terms, right? Are they common factors? Yes, I pulled out 2x, right? Afterwards, the expression represent a difference of 2 squares? It did. It was x squared minus 49. 49 x squared, both perfect squares. So I broke it down like this: a minus b, a plus b. So it's a little flowchart. Or if you have 3 terms, are they common factors taken out? If not, are the first and last terms perfect squares? For number 1, that was not the case. We had 48. So no. So then is length coefficient 1? No. Then just use 9 and you're good. Right? So that's something that could help us with factoring, if you think that will be beneficial. So like for number 3, I did this one kind of quickly. Okay, for number 3, so I guess I had a hard time factoring this one, so that's something we should talk about. Remember, and today's homework quiz is going to be on factoring. So maybe we'll do a little practice beforehand because I want to make sure you guys are cool factoring. You have 2x squared plus 3x minus 9 equals 0. You could do that. I got lazy. I didn't do the diamond. If you do the diamond, it looks like this. So what would I put up top if I do the diamond for this? What's a times c here? -9. So -18. What's my b value? What two numbers multiplies at the top, but out to the bottom? Great. And then because the leading term is 2, it's going to be 2x squared and -9. Then you put the split term, 6x and -3x. So you get x and 3, 2x, and -3. Yep. And that's how you factor it. But some of you guys stop there. You gotta keep going because it says solve, right? It says solve. So you had to go an extra step and tell me that, hey, when this equals 0, x equals 3 halves. When this equals 0, x equals -3. Because remember, we're doing the zero product property. Anything times 0 is 0. So these are two things being multiplied together. One of these two things has to be 0. So what values of x would make each of 0? This would be 3 halves, and that would be -2. I feel better about this now. So you guys had some trouble with this, but we did on the walls yesterday, so I feel much better now about plot form. And the homework last night I had some plot form, so yeah. Anyway, actually, the homework last night plot form? No, it did not. It did. Yes, right. See, my short-term memory is terrible, right? So, yeah, duh, of course it did. This was a little funny because what happens, you get root 12. Now, be very careful. What factor of 12 is a perfect square? 4. So you pull it out. When you pull out root 4, it becomes 2 root 3. 2 root 3 and root 12 are identical. Why am I doing that? Because now what happens, this can be rewritten like this. Now you're allowed to do that if you factor something out, because that 2 that I pulled out, how's this 2 connected to this group here? Is this 2 being added to this? Is this 2 being subtracted to this? Multiplied. What's opposite multiplication? And isn't this division here? So they can cancel out. You totally can get away with that. It's totally fine. And leave this, right? What I don't want you doing, this is actually my biggest pet peeve. Please don't do this. I will kindly let you know that you can't do it. But if you keep doing it, I will be less and less kind as time passes. Some students will do this and just cross off those 2's and completely neglect the math. You just gotta cross that off also. Some or maybe before you even get to this point, so we'll just say, oh, 4/2, let's just cross it off and it's all good, right? You can't do that because that's a PEMDAS error. So that's a order of operations error. Because this 4 or this whatever is being connected to the other thing by plus or minus. Division is not the opposite of plus or minus. Totally not, right? Because then what you're telling me you could do this. I've got 4 plus 7 over 2. Can the 4 and 2 cross off? Yeah. No, because it's supposed to be 11 halves, right? If you do order of operations correct, it's supposed to be 11 halves. But if you do this, and yeah, it's 2 plus 7 is 9. No, there's one of them's got to be correct, or definitely one of them's wrong. So you can't do that because you have to imagine when you have a big fraction, there's actually an invisible parentheses here. Actually, I probably prefer you do draw parentheses so you protect it and take care of it, and then cancel afterwards. So be very mindful about that because that's a very common error that happens. These were okay. 4 root 3, 20 root 6. 4 times 5 is 20. Root 3 times root 2 is root 6. Not much more you can do about that. 16 is a factor. 40 is to pull it out. This was okay. Some of you guys did okay. Some of you guys had a little trouble. I decided to move the 10 over to the right side, make it 6 over 6, because that's same as 10, maybe 6 5 over 6. And then I multiply both sides by 3/2. And then things cancel 3/6, you can cross cancel. So it becomes 6/5/4. You can also initially multiply everything by 6. So actually, I don't know why I didn't do it that way, because that's how I usually teach it. If you so desire, you could have started the problem off by multiplying both sides by 6. So you get 5. And you get 4x minus 60. So 4x equals 65. X equals 6/5/4. So you do that. That's another way you could approach it. For 6, move the 4 over, square both sides. Solve, pretty easy. That's 3. And it makes sense when you throw 3 back in, because you get root 9 plus 4. So 3 plus 4 is 7. For 7 and 8, cross multiply. When you have exact one fraction, you can multiply this to this and this to this. So you get negative 4x minus 4, you get 6x, work it all out, you get negative 2/5. For 8, distribute, combine like terms, should be fine. No problem there. And yeah, that's good there. Questions about 5, 6, 7, 8? No, okay. Yeah. You can cross multiply because you have exact one fraction on each side. Technically, what you're doing is you're multiplying both sides by x and also multiplying both sides by x plus 1. Because those are both your denominators. By doing that, what it enables you to do is cross stuff out very easily. See, these x's cancel. These x plus 1s cancel. 6x equals negative 4x minus 4. It's just a cleaner way of doing the problem. For 9, yeah, I think you guys maybe ran out of steam or just, threw in the towel at this point. If you guys forgot substitution, you can get one letter by itself. And then substitute. You could do that. You could also do elimination. I don't know if anyone approached it from that perspective. I can't remember. If you do elimination, you could maybe eliminate the y's, multiply the second equation by 3. So then you get 2x plus 3y equals negative 5. 9x minus 3y equals 27. 11x equals 22. X equals 2. If x equals 2, then y will equal negative 3. So you can plug it back into the equation and solve for y. So cool. For 10, you should get 5/1 for the slope. You subtract the x's, subtract the y's. Yeah. And then you could plug in either 4, -2, or 5 or 3. Some of you guys have some trouble with this. We'll definitely talk about this tomorrow. But you guys are familiar with y equals mx plus b. It's point slope, slope-intercept form. Yeah, you gotta find the slope, subtract the y, subtract the x's. Plug in either point for x and y and solve for the y-intercept. So for 11, um, yeah, just get y by itself. That's probably the best way to do it. And also, if you see the pattern, if you plug in -6, -3, you start noticing that y increases by 2, as it should, because as x goes up by 3, y goes up by 2. Slope's 2/3. And the graph it. Some of you guys were okay with that. Some of you guys need some work. So make corrections. again, I'll post the schools when I get a chance. We are going to talk about this topic for sure tomorrow. So we're gonna correct this. And if I go back to Delta Math, and I think we're gonna try some time for Delta Math too, because we definitely want to get that done. Because that would be kind of weird if you finish this class and you don't get Delta Math done because you should get it done. So for example, required, and yeah, obviously I have so yeah, so Bella, you're in my class, Jake, you're in my class. Who else is in my class in this room? Anyone else? Hold on, let me find you. Should be in here. We have so many wait. Oh, you know what? It's everybody. It's Mr. Davidson students also. I was like, what? I don't have this many students. What's going on here? No, I gotta look somewhere else. I have to look at the attendance system. Well, anyway, I was like, whoa, like I was freaking out. Like, I don't have this many students. Anyhow, yeah, he hasn't done crap. Okay. Um, but here are the skills, right? Like multiply binomials, squaring binomials, factoring, things like that, substitution, elimination. So you can see all those skills there, right? But I made a new one, extra practice. I share this with everybody. So ultimately, I'd like you guys to join this new group I made, and this has quad form, solving quadratics. Might be some repetition from this other summer assignment, but yeah. So so Jake, you finished it, right? Yeah. And who else finished it? You did. Oh yeah. So if we have some time, you can do the extra one. So all right. So okay. So I think that covers this. Let's now do the lesson for today. Here we go. And hopefully we get through this pretty quick. And today's homework was really short too. So we'll do that in the end. Okay. We're gonna talk about terms today. Lots of stuff. Angles. We'll try to go for a break around 9:50, 9:50-ish. Good time to take a break. Okay, let me pull it up. Sweet, here we go. Okay. So, point. How the heck do you define a point? I mean, it's such a weird thing. Thanks. I'll just call it a dot. So, what are some examples of points like D, E, N, A? Those are all points. Yeah, those are points. So, okay. A line is a set of infinite points. And it's one dimensional. So it's one dimensional, just so just a set of straight. Maybe like that. It's straight. Sometimes people say you have a straight line. Well, yeah, of course, all lines are straight. But um, so that's that. A plane is gonna be two-dimensional. And it actually is infinite as well. It's actually a set of infinite points and lines. So for example, I could put a bunch of dots here. I could just keep going. I could draw a bunch of lines here. And by the way, both these have no boundaries. Just like our US president. Let's stop there. Okay. Sorry, I get political sometimes. No boundaries. This goes on forever. By the way, I don't like Democrats here, just so you know, so I'm not being forward one sided. But so this goes forever, right? So even though it looks like it's constrained, you can just expand everywhere. Line goes a line goes on forever, right? Both directions. So even though we draw it like a parallelogram or whatever, planes do go on forever. Okay, so a point is just a dot, like just it's a kind of, so this is kind of like the food chain, right? Like this is the bottom of the, the food chain, the point, then the line, then the plane. Now space. Now we hear the word space, given what we've been talking about so far, you have a dot, you have a line, you have a plane. How do you think I would describe space? How many dimensions does space have? Well, it's infinite for sure. It's three-dimensional though. So that box of chips, that's like a box. That would be 3 dimensions, right? Because if you look at that box there, you have length, width, height. You have 3 dimensions, right? If I draw a box, so space is gonna be 3 dimensional. It is infinite too, yes. It's actually a set of infinite planes. And points and lines. So one example would be like this. Say I just drew a box. But it goes on forever. So it just goes on forever. That space. Yeah, usually I draw like two rectangles off center and I kind of connect the corners. That's how I draw my boxes. But yeah, that's space. So like volume, right? That's one way of thinking about it. So a lot of terms there. Oh, can I see? Hold on. I want to see. Oh, that is good. All right, that was never really an artist. Okay, let's keep going. Can I clear the screen? Yeah, okay, cool. Collinear. So co means the same, and linear means line. So just basically points on the same line. So you want to make sure you're comfortable that when you're told something's collinear, then you know what to expect or how to set something up. Non is the opposite. Points not on the same line. So for example, let's switch colors for a bit of contrast. So I could say, well, actually, nothing was really drawn in a co. I mean, any 2 points make a line, but like where points are not collinear, I'd probably say L, S, and K. Right? There's no way L, S, and K are all on the same line. That's pretty obvious. It's kind of hard way to draw on. I don't think any of these I mean, sure, S and K are collinear. Any 2 points can make a line. That's true. But are there 3 points on this diagram that are on the same line? I don't think so. I mean, you can say maybe PUG kind of, but you have to have it obvious. So coplanar. That's when you have two lines or actually I don't want to say 2 lines. Points and lines on the same plane. And of course, not on the same plane is non-coplanar. An intersection is are points and lines in common. So look at this line here that claims point U. Is that line common in both planes? Yeah. These 2 planes intersect at that line there. Or if you were to draw 2 lines and they touch, that the points where they touch, the point where they touch, the 2 lines touch, would be an intersection. So those points and lines are uncommon, are intersection points where they meet. Okay, now we get to more fun stuff because I just really don't like doing the terminology, but we have to do it. Do you guys get all that? Okay, cool. So now let's talk about okay, a little more terminology, but then I promise we get to more interesting stuff. Angles, yes, we talked about this the other day. An angle is when you have 2 rays that have the same endpoint. The similar endpoint is called the vertex. So in this case here, so my sides would be OD, ray OD, and ray OG. Vertex is point O. And you call this angle DOG. Or you call it angle GOD. Now, here, which is angle Q? Um, well, it's the vertex. It's pretty obvious. And there are 3 ways you can name it. You can call it angle PQR. You call it angle RQS. Or you call it angle PQS. Acute is less than 90. Acute equals 90 degrees. Obtuse is greater than 90 degrees. And straight's 180 degrees. So this will all kind of give you a little head start. And by the way, you see the little angle symbol? You see M means measure. So this is indicating I want to measure angle 2 whatever that is. By the way, these are not angle symbols, just to know, these are, you guys thought these were less standard, right? Okay, so make sure, because my handwriting's not fast, but these are angle symbols, right? Where you kind of draw it like flat, and then that, this is supposed to be actually more, those are supposed to be bends. Okay, let's keep going. Let's keep moving here. So if I measure angle COD and BOE. Okay, so if you look at where's C located right now? It's kind of hard to tell. 145, right? And D is at 60. So that's gonna be 85 degrees, I think. Yeah. You guys see how I did that? It's called a protractor. The old device. I'm not sure we have any. That's today, so it keeps them. But yeah, you just subtract those two. So what you do is you draw an angle. If you have an angle, you use this little contraption. That's like a ruler in a way, that's a semicircle. Helps you measure angles. So I'll keep my mouth shut. What do you guys think B at least can be? Based on where B is, what we and O are. Yeah, 25, yeah. 25 degrees. Okay, find an acute angle. You can say angle BOE is acute, right? It's less than 90. What name for me a right angle here?
XOB.
I like it. Yes, XOB is 90 degrees. Yeah, this is where I get a little lazy here. XOB, love it. Or BOX. By the way, only thing that matters, the vertex has to be in the middle. Vertex has to be in the middle. That's the only thing that matters. You could do BOX or XOB, it doesn't really matter. Name for me an angle that's obtuse, more than 90. BOC, I love it, yes. Or COB, however you want to call it. Outstanding. Give me a straight angle. BOA, 180. Or AOB. Okay. Congruent just means the same. So yeah. So you'd write like this, by the way. Angle GAH. And we do this symbol here. You do a little squiggly line with an equal sign. Angle JEI. By the way, you could also call this angle HAG. Or angle A. You call this angle IEG. Or angle E. So you totally could do that. That's fine. Where it does get a bit ambiguous is going back up top. Actually, before I move up, any question on this? So again, you call it GAH or HAG, or just angle A straight up, because that's vertex. You can call it angle X. Where it does get a bit ambiguous is the second angle here on this page. If I said angle Q, it's kind of confusing. Now I know what that question means. Okay. Yes, Q is a vertex. Sorry, I didn't see that. Okay, this is a bit ambiguous. If I say angle Q, do I really know what I'm talking about? No. Because it could be any one of these three possibilities, angle 2, angle 3, or a combination of angle 3. Yes, Q is a vertex. Sorry, that was a bit ambiguous, that question. I should have realized that. But you get the idea now. Okay. Angle addition postulate. After this, we could do a break. This will be a good place to come back and finish out the rest of these notes. And then after that, then we'll do some delta math, and then we'll do the homework quiz near the end. And then Adam, we'll have you do the homework quiz before you leave today. Yeah. So just the last part, and then we'll take a break because we're getting close to 10 o'clock. Oh, one thing too that we do want to be mindful about. During the break, if you guys can just not be on your phones, we're just gonna be a little adamant about that. So, just something to keep in mind. Angle addition postulate. Just like the segment addition postulate. So F is the interior, so you can say angle DOF plus angle FOG equals angle DOG. And if angle DOG is a straight angle, and F is any point not on line DG, so let's say it's like right here, then you could say angle DOF plus angle FOG equals how many degrees? If we're making a straight angle here. 180, yes. Because we're forming a straight angle. Okay. I think that's a good place to take a break. We'll come back and do some practice on this stuff. We'll talk more about angles. So let's take a break. Come back at 10 o'clock. Okay. Let's talk about how we will use the angle addition postulate with some algebra. So here, measure angle, find the measure of angle AOD. If AOD is 4y minus 8, so this right here is 4y minus 8. DOC, let's use a different color. I'm gonna sneak that in there. Kind of looks like a brown face. You guys see that? The two eyes? Yeah, I didn't mean to do that. It just happened. Okay, is y minus 11. And COB, let's use some more vibrant colors. That would be y plus 13. Now, what do you think each of those three colors, green, red, and blue, what do you think each of those three, not each, all three of them combined would add up to? Correct. Because that's a straight line. AOB is 180. This angle plus this angle plus this angle all make up AOB. So just so we're clear, we'll write out the angle addition postulate in all its glory. Angle AOD plus angle DOC plus angle COB must all add up to 180 degrees. So guess what? 4y minus 8. Actually, let's go back to our vibrant colors. 4y minus 8 plus y minus 11 plus y plus 13 must equal 180. Does that make sense? How I set it up? Right? Just be very methodical about it. Now at this point, it's all out, right? That should be 6y minus 6, I think. Yeah, 6y minus 6 equals 180. 6y minus 6 equals 180. 6y minus 6. Add 6 to both sides. I'm running out of space, but that's okay. That should be 31, I think. Yeah, 31. Okay, we're good? Good, okay. So go and try the next one. I'll label again for you guys. We'll use some different colors. PERREP, another frown face. 4x minus 4. And that let's use orange. REA or AER is 3x minus 2. And the whole shebang, PEA is x squared. I'll work it out too. Go ahead and try it out. X squared. Yeah, we don't know. We don't have the numerical value for the whole thing, but we do know that the combination of these. So guys, purple plus orange equals what? X squared. Purple plus orange equals x squared. Yeah, so you got to add those expressions that equal x squared. Sorry, pink plus orange. That's not purple. That's pink. I should know my colors.
Oh.
Okay, that's what I got. 4x minus 4 plus 3x minus 2 equals x squared. Angle addition postulate, AAP for short. Move everything to one side, factor it, x minus 1, x minus 6. So this is an extension of factoring, right? So we're building in this algebra skill into the geometry problem now, right? This is great. This is beautiful. I love this problem. Definitely for you guys take geometry next year. I'm putting this on the test. I don't know what test this will be, but it'll be on the test. I like this problem a lot. I love it. I will definitely, make sure Mr. Davis has this on the test. Because I don't know when, maybe in September, October, November, December, I don't know. But here's the problem. Here's why I love this problem so much. We get two answers at 1 and 6. X equals 1's kind of weird. Why is x equals 1 kind of weird? You put 1 in, what happens?
Zero.
Yeah, and that doesn't look like a 0-degree angle, right? I mean, because it just wouldn't exist. If it's negative, that's even more of a problem. But I would discard 1 and keep 6. That'd be 20 and 8, 16. 20 plus 6 is 36. That 6 squared is 36. It makes sense. It's a great problem. Okay. Question on that one? All right, let's keep going. Adjacent means next to. So two will plane that have so they have the same vertex. Actually, yes, they have to have same vertex. That share a side or have a common side. Use proper grammar. And I'm trying to think why the 3 bullet points. I don't know why. Yeah. I don't know why. You could say, yeah, I don't know. Yeah, I don't know. But this is yes. This is yes. This is no. No. And no. It's pretty clear they don't have the same vertex. It's pretty clear they don't share side. And they also don't share a side here. Oh, now I see why it's the third bullet point. Now I think now I see why. I think I'm trying to think how would I say this? So clearly this is not the same vertex. Clearly this is not common side. 10 engulfs 9. So I'm trying to think how would I say this? I think you could say it both form a bigger angle. If that makes sense. You see how angles 1 and 2 form a bigger angle, right? 3 and 4 form a bigger angle, but do 9 and 10 form a bigger angle? Because 10 engulfs 9, right? So that's another way of thinking about it, I guess. That's kind of I'm trying to think of the right way to articulate it, but maybe that makes sense. I don't know. I'll do better when we actually teach this in the fall. Okay. Those are called adjacent angles, just so you know, just so you come to that terminology. Bisector. It sounds like intersect, and bi means two. So you just cut into two equal angles or congruent angles. Two congruent adjacent also angles. So in this case, angle AOC, kind of like the Congresswoman, is congruent to angle COB. That's because we get that means because we cut angle AOB in half. We cut it in half. So some practice. Why don't you guys just try this on your own? Just try it. See how you guys do. I'll come around and help you guys out. I'm gonna freeze the screen and work it out first, and then I'll come around and help you guys out. How are you doing? You help out. You little push. So, something from what word is there? Awesome. Point. So Z, the corner, Z, right? So the vertex is. No, right. And the common side, Z. It's not one right, Ray, yeah. That's common side. Or you put a little symbol, or so, a little arrow, obviously. Yeah, that's right on top of it. Yeah, so it's an arrow, over. Yes. Correct. Just the rest of it. That's it. Two. Yep.
This is my interesting.
Now let's look at measure angle VCP.
It's like, you know, calling.
That's it? They're easy. Well, that's 20 and 90, right?
I don't get my advice.
Just left over.
Plus M plus M reason.
Not, one.
Maybe we're supposed to be calculating what the numbers are
Yeah,
supposed
seven,
to be.
seven.
Because we have 3 degrees.
No, 550.
Right, right.
So, but bunk heading, so, if I tell you,
90 degrees.
AZC half, that's 70.
So we have to get the rest.
So angle one.
We're supposed to be doing these.
Oh, that's 35.
So we calculate the rest.
Well, actually, no, you want to end of angle one.
So then.
Yeah, exactly.
How much is the right?
Your,
80 degrees, so that
measure, no measure is two. The measure means, if you're saying the angle first, you're not saying the value. The equal value. Value. Now, it's 1, 2,
So then 90, 20, you said this is about 60 degrees,
yeah, this is.
so then what's without the 20? Without the 20? So then 90,
But
this looks pretty.
then we use 36, is you can make an equation, 20 plus 3x minus 5. Yeah, are we doing yours? Yeah, we're at.
What the heck?
Yes, so there's just angle AZC. So AZC,
Here's 80.
so that's 20 and 90, right? So how much do you have left for AZC?
Equals 70.
Don't worry about
They're
that.
both 70.
Just look at this right now.
They look pretty
So that's 20
familiar.
and 90.
No.
Actually, yeah, you have it right here. 35, 35. Seven,
The
yeah.
other one. 5?
No, we're looking at AZC.
Oh, I mean.
So that's 70 degrees. Then it cuts in half, which right to compare up, 35, 35. So you know measure angle one equals measure angle two,
Probably.
which equals 35.
Oh,
Right. And then the rest should all fall in place. Good, great. But you also say for measure angle, AJC, it equals 70 degrees.
Okay,
Because you want to.
okay.
Whatever there's an M there, you have to give it a numerical.
What?
And likewise here, you want to say,
Four.
Okay.
is 90.
We didn't do four.
One goes out.
What's five?
No, no.
Good. Don't, great.
Just like trying to figure out.
That's interesting. That wasn't.
Wait,
Oh, the next one.
Yeah, good, excellent, got it.
what's it on number 6? What is it called?
It's 90. Actually, formally got a right angle. Are you a Packers fan, Jay?
What?
Are you a Packers fan?
Yeah.
All right, I feel sorry for you.
Why?
Because we keep beating the playoffs, the Niners. I'm a Niners fan. Yeah. But but the Packers used to be the Niners all the time in the 90s when they had Brett Favre. I saw Sterling Sharp was going to the Hall of Fame, which is kind of neat.
Yeah.
He was really good. Yeah, unfortunately, he had a neck injury. No, I respect for the Packers. I hate the Cowboys.
Yeah.
Cowboys I cannot stand.
Can't win a playoff game.
True. But back in the 90s, they were winning it all the time. So they were very annoying.
Like I hated the Patriots during their run.
I have respect for Brady, though.
I actually really like Brady.
After he beat the Falcons, I was like, okay, like he is the GOAT at that point. Like, I know Montana's great, but
I don't like Mahomes.
yeah, Mahomes there's a lot of hate with the Chiefs, especially because now Taylor Swift is kind of in the mix with all that stuff. But
Outside of football, he's fine. But
I'm actually glad the Eagles won last year.
yeah.
Yeah, because I hated the Eagles actually 2 years ago. I could not stand them. So
Packers are close. beating them.
Yeah,
We just played that off.
but yeah, I mean, anything goes. You never know what's gonna happen next year.
I
So
think this was our year.
Niners could get back in. I don't know. Let's see. I do think Washington looks pretty good. Yeah. Detroit, they're still in there. Okay, no worries. And then we'll just go over this stuff.
I think Detroit's been really good. They got 85% back this year.
Yeah, who they lost to Philly, right? In the playoff, or they lost Washington. Commanders, right? Yeah. Okay. Oh,
Oh.
okay. Here we go, guys. Oh shoot, I wrote that wrong.
Oh, the Niners. Oh,
Oh, fine.
Three?
Yeah, you got it right. Oh, yeah. I got it right the second.
Okay, let's run through this. I came around, kind of saw how you guys are doing. You guys are making great progress. So for angles 2 and 3, they share point Z as a vertex, and the common side is oh, sorry, it should be ZA, not AZ. Yeah, it should be ZA. ZA is a ray that's shared between angles 2 and 3. Angle 1 is adjacent to angle 2. And you know, it's also next to this right angle as well, but acute angle will say that. EZE, just look at 20. CZE's right angle is 90. And what's left over for AZC or whatever is 70 degrees. So ZB cuts this in half, that's 35, 35. And then 1, 2, 3 out to 90, because that's a 90-degree angle. And then you can use the angle between partial down below. So go and, you know, take some time. Go and simmer on that a little bit.
Maybe.
Okay, questions? All right, let's keep moving. I got one more page and we'll do some delta math. Okay. What assumptions can we make about this diagram? What can't we assume? Well, I don't know. No, we can't. Actually, we can't assume that.
EDC.
You need a right angle symbol. Do you guys see a right angle symbol? So you can't assume it. So in red, I'll write what we can't assume. In green, I'll write what we can assume. We can assume that angle ABD plus angle DBE plus angle EBC equals 180 degrees. And that's because you have a straight angle. Straight angle for angle ABC. So I think that's good enough. I mean, I gave one assumption we can make and one assumption we can't make. Because I think it's common, because someone said it. Like, oh, it's right angle, but it's not because we don't see the symbol. But definitely you can assume that all three of those add up to 180. So hopefully that makes sense. I won't erase the screen just yet. Complementary means add up to 90. So if that's true, you can say angle A and angle R are complements of each other? Likewise with angle SHK. And angle KHR. Okay. So angle MAC and angle ACY are supplements of each other. Here, yeah, you can say angle BET and angle TL. And finally, for vertical angles, those are angles opposite of each other. So the sides of one angle are opposite rays of the other. So these are so those are vertical angles. And they're always congruent, by the way. So angle and angle 3, that's supposed to be an and symbol. As well as angle 2 and angle 4. We call those vertical angles. Yeah. Okay. So yeah, what's happening? Okay, so let's go ahead and start some delta math. Actually, let's do this. Let's do the homework quiz first. And after you finish it, you can do some delta math till we finish class today. And I'll come check to see where your progress is. If you haven't really started, don't worry. If you're starting it today, don't feel ashamed. It's all good. But I just need to see where you are. So I want to make sure we finish by the time we get to this time next week. So, but we'll start the homework quiz. When you're done with it, then yeah. Homework 2, day 2 homework. You go now. You're good. I'll see you tomorrow. Let's try this delta math thing. Yeah, once you finish this and turn it in, then I want to work on delta math.
Yeah. We used to make you more.
Day 2 homework, yeah.
Day 3.
Day 2 homework.
Oh, day 2, remember?
Yeah.
Oh, that's right.
Because it's always 2 days behind.
Well, this is a lesson.
Yeah.
Yeah.
And if you want to use a lesson, you can use the day 2 lesson as well.
Oh, that's fine.
Because the day 2 homework didn't have simplified radicals. So the day 2 has.
11.